Okay, hello students. I hope everybody is doing fine. Let's talk about reflection and echo in the topic of, or the chapter of sound today. Okay, so let's quickly dive into the sound reflection part. So light exactly just like, sound exactly just like how light reflects. Similar way, sound also reflects. Okay, sound reflects. Okay, so the part of sound bounces back into the same medium. So, for example, there came a wall or a structure, so sound will hit it and will come back into the same medium. And sometimes some part of it gets absorbed by the surface as well. Okay, so this sort of phenomena leads to two kinds of situations, that is echoes and reverberation. Okay, so we'll discuss what exactly these two terms are. Okay, so reflection of sound. So let's talk about, sometimes you might have been in a, gone on a trek to a mountain. And if you will scream, there are echo points there where you will scream some name, your own name, and you will call hello. So you will hear the sound back like hello, 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 like that, right? So that is very fun thing to do, but actually it is related back to science, that how or why the echo is being formed. So what happens? The sound goes to these, distance of cliff faces, and it reacts. Okay, not reacts, it reflects back. Okay, so here it will go from here, maybe on this hill you are standing here, and you are saying something, so it will go and hit back and come into the same medium, and it will reach your ears and will be able to hear, okay, distinct echoes of your similar kind of sound. So that happens because of, no, not other person is not standing there and just calling out your name. No, you have done it, and now the sound is being reflected, okay, of distance clip faces. Okay, and because of that you can hear the sound. So whenever it hits a hard surface, it will reflect back. Now in empty halls also, if you have not been to a mountain, you can go to a very big empty hall, or when you are maybe shifting your houses or rooms, and when room gets empty, then also sometimes you will hear echoes. Okay, so that is also, or if you will clap, you will hear clap coming back to you. You can hear the same sort of clap, whatever pattern you were clapping your hands in. So clapping in an empty hall creates multiple reflections, and it comes back to you and you can hear it. And best reflector, so what would be the best reflector? It should be hard, smooth surfaces like marbles. Okay, walls, you can say, or metal sheets. They reflect the sound more better. So it should be a hard solid surface, but also smooth. Okay, now laws of reflection, what does it say? So just like I told you that, the just like the laws of light, okay, how light reflects, similarly sound also reflects. So the first law would be the angle of incidence. That means, from, suppose the sound is coming from this angle, okay, and it's hitting the surface, will be equal to the angle of reflection. Okay, and the incident wave, the reflected wave, the incident wave, the reflected wave and the normal this normal lies on the same plane. Okay, so everything will be happening in the same plane. So if you can remember, the light chapter, you can easily recall the sound as well, the laws of sound as well. So this, I hope, is easy for you, because this will come from if you throw a ball. Okay, let's imagine a ball. You throw a ball, it will hit and it will come back, reflected. Okay, now if you draw a perpendicular to this, you will find that this angle and this angle is equal. Angle I is equal to angle R. Okay, so that is what is being said in the laws, and every wave is in the, all three are on the same plane, lies on the same plane. Okay, now echo, what exactly same plane mean? I have explained in my previous sessions. If you do not have, like, if you don't have access to it, or you do not understand, you can just ask me and I'll just tell you. Like, you can just comment maybe, or maybe you can contact. Okay, let me, yeah. Okay, echo. So now what exactly do we need for an echo to be reflected back to us? So the first thing, let's say, would be, sorry, yeah, So first thing would be an echo is what exactly echo is? It is distinct repetition. Okay. So what happens is, if I'm like I said, hello, so I'll hear it back. Hello, 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 like that. Okay. So this is being distinctively repeated. Distinct means there is no hello, 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 not like that. Okay. Not the voices are not on the top of or overlapping each other. They're not top of each other, right? They're distinct. Hello, hello, hello. They're not like hello, 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 hello. No. Okay. I hope you're getting my point. So minimum distance needed. So what is the need of echo to be produced? So the first is at least 17.2 meters of distance you need between the sound source and the reflector. Okay, so if this is a speaker and you have kept it here, so there should be 17.2 meters of difference or distance between the reflector, the surface, the hard surface, which is going to reflect it back. Okay, and the source obviously. Now time, at least 0.1 seconds time gap between the original sound and its echo. So if it is going there and coming back, at least it will take 0.1 second to come back, the echo to be formed. Okay, and last, surface requirements, like I told you, hard smooth surfaces will be needed, and open space. In an open space, reflect sound the best. Okay, so in an open space, it can come back to you easily without getting reflected to another surface or another area. Okay, now let's do this. Okay, let me just first, this I will explain you later. Okay, let's talk about here now. Okay, so the distance, the formula of echo distance is basically distance is equals to speed of the sound into the time interval between the sound and the echo. Okay, what do we mean by that? If you have to calculate the distance to the reflector, okay, that how much distance from the source to the reflector is, what you can do is you can calculate the speed of like you can have the speed of the sound, which you already know at room at 20 degrees Celsius, it is 343. Okay, and then you can multiply it with whatever time was taken. Okay, so the time interval between the sound and the echo. So if sound reached here and it came back, so what was the time taken in this to happen, this thing to happen? Okay, so let's say some time would take, like, I'm not going into the specification, we'll see in the example. Okay, and divided by 2. When you will solve this, you will get the distance of the reflector, that how far is it. This is also used in sonar. Okay, sonar, what exactly it is, it's not there in your syllabus much more. But sonar, and you can say to calculate the enemy submarines and all, I have told you already, right? So underwater also the sound will reach and it will reflect back, and that's how we'll calculate the distance by the speed of the sound in water at certain temperature, and also when it is hitting back at what time. So we can calculate the distance of something underwater, fishes or anything which we want to calculate. Okay, now let's take an example. So if an echo returns in 0.5 seconds, so we are given with the time that is 0.5 seconds at the speed, sound speed of, so speed is also given to you, that means velocity is given to you, that is 343 meter per second. This is in seconds. Okay, now you can calculate the distance easily. So you can just do V into T upon 2, and you know that it is 343 into 0.5 upon 2. And once you will calculate it, you will get somewhere around 340. Okay, it's written here 85.75. Okay, so you can calculate it. It's okay if you can't calculate it very fast. You have to just practice more and more, so you'll be able to do it. So applications, again, we already know, I told you, right? Sonar is basically, what is the full form of sonar? Sound, navigation, and ranging. So sound, okay, sound, this O, sound, right? Navigation, and ranging. Or you can just take A from here, right? And ranging. So this is what it means. Now from sonar, you can calculate this, how much time the sound is taking. to reach and reflect that surface, whatever surface is there, and also the speed of the sound, right, in water at certain temperature, and then you can divide it by 2 to calculate the distance between the fish and the whatever device you are using. Okay, medical ultrasound I told you, and to calculate distance between mountain, depths of well, and in construction. This also you can understand now. Okay, that how echo works. Now there is a difference between echo and reverberation. Okay, like I already told you, echo is very clear and distinct repetition of sound, and it takes more than 0.1 seconds of time gap for the original sound and the echo. Okay, but reverberation is the overlapping sound due to multiple reflections. So suppose if you're seeing something, so it is multiple times it is getting like reflected and then reaching you again and again and again. So it's overlapping, like hello 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 hello, hello, on that. Sometimes on mics and all you might have heard that. So that is reverberation and nothing else. Okay, and it takes less than 0.1 second because that is happening multiple times, right? It is over, the sound is overlapping, it is getting reflected and being overlapped on each other, and that's why it is sounding like in a multiple terms, and it is not very clear to you because in mics also reverberation is there, so you won't be able to sometimes easily understand what they are saying. Okay. Okay, persistence of original sound, and here heard as separate sound. So this is persistent, the sound is repeating again and again, the original sound. Here, heard as separate sound. Example, yelling in mountains. Example, clapping in auditorium. So if you clap in auditorium, it will be like a lot of clapping you will hear. So that is because of reverberation. Okay, right? So now let's do some questions. Okay, so the first one is echo is heard when the reflector is at least 10 meters, 17.2 meters away, 20 meters, and 25 meters. So this we have done. I don't think you have any doubts. Okay, which surface is best for reflection? Cloth curtain, wooden board, soft cushion, or grass? Okay, and last one is if the gap between sound and echo is 0.2 seconds, then speed of sound is given to you, that is 340 meter per second. So calculate the distance for the reflector or of the to the reflector. Okay. And last question is that it can be a little bit challenging, but you try answering that in the comment as well. Why can't you hear an echo in a small room? What could be the possible reason? The answer is in the first, you can say question. Okay, so summary is totally, if we would like to summarize everything. So reflection of properties we have discussed here. Okay, reflection properties basically how or reflections are being caused and what kind of surfaces should be needed, right? Then we talked about law of reflection for sound, which is almost similar to the law of reflection for light. Okay, so angle of incidence is equals to angle of reflection. Then we got to know about the echo condition, that it should be equal to or more than 17.2 meters. Now you can go back and answer your previous question. Okay, and with time gap, what kind of time gap needed for an echo to be produced, that is equal to or more than 0.1 seconds. But about reverberation, if we talk about reverberation, it takes less than 0.1 seconds because it is overlapping. Okay, and sonar, ultrasound, seismology, distance measurement we have talked about. So thank you so much for joining the session. I hope you enjoyed, and you can like, dislike, or let me know the feedback in the comment section. And also if you have any doubt, you can ask me there or check out my profile. Take care. Bye bye.